Good morning and happy Monday. So just to recap on last week, we did the properties of quadrilaterals. So we had trapezoids, we had isosceles trapezoids, parallelograms, rectangles, rhombi, squares, and kites as well. So went through all the different properties, talked about maybe how to prove some of those properties existed, and then how to answer algebraic questions using the properties. This week, it's going to be a couple of different things. We're going to start with looking at proving properties on a coordinate plane. So we're going to introduce the coordinate plane and then how we can show the properties exist on a coordinate plane. And then maybe a couple of other odds and ends that I want to throw in before we move on. We're also going to talk about surface area and perimeter of 2D shapes and how we can do that with quadrilaterals as well. On top of that, please make sure that your posters got turned in. And then for this week, it is a shortened week. So we have Monday, Tuesday, Wednesday. Thursday is a teacher work day, and Friday is spring break for you guys. So what I would like you to do is try and complete this lesson, the work that goes with this lesson. So there's a packet that will come with this one. And then you also have a quiz to take in your own time. Please try and have everything done by noon on Wednesday. Thursday, I will be grading some stuff, but really if you can get it done by Wednesday, that will be awesome. And then Thursday, I'll get all my grading in submitted for term 3. All right, so for today, prove the properties of a shape using coordinates. So can we prove that if we're given 4 coordinates that it makes up a parallelogram or a rhombus or a kite or whatever it is? And then say I give you 3 coordinates and say, okay, I want you to find the 4th coordinate that would make this shape a parallelogram. How would you do it? So your essential questions for today: how do I prove that sides are parallel or perpendicular? And then how do I find a missing point on a shape using its properties? Okay, so first up, here's the scenario. You're given 4 coordinates and then asked to classify the quadrilateral formed and prove why it is that particular shape. So here's 4 coordinates, and I want you to show me that it is a parallelogram, trapezoid, isosceles trapezoid, whatever. So how would you do it? Some things you have to think about. Okay, what were the properties of that shape? So when we talked about classifying quadrilaterals, we talked about, okay, what do we know about the sides? What do we know about the angles? What do we know about the diagonals? And then are there any symmetries that we needed to worry about as well? So how do we show those things exist when it's on a coordinate plane? Well, first off, you can prove sides are parallel. How do you do that? You use slope. If you want to prove they're perpendicular, also slope, but remember in parallel lines, the slopes are the same. In perpendicular lines, they're the negative inverse of each other. And then if you want to prove lines are congruent or equal length, we use something like the distance formula, or you could use Pythagoras' theorem as well. And say we want to prove that the diagonals bisect each other. Well, could you show me that the point where the lines intersect is a midpoint, so therefore the 2 segments on either side are congruent, and again using distance formula or Pythagoras' theorem to do that. Recap on our formulas: we have slope formula, which is the difference of the y values over the difference of the x's, also known as the rise over the run. Remember, we read slope from left to right. So if a line is going up from left to right, it will have a positive slope. If it is going down from left to right, it should have a negative slope. The distance formula. So this is y2 minus y1 to be squared, x2 minus x1 to be squared. Add those together and then take the square root of them. This had its foundations in Pythagoras' theorem. And then the midpoint formula. What is the average of the x points and the average of the y points? Add them together, divide by 2. Your answer is still a coordinate. Okay, here's our first example. We've got 4 points, A, B, C, and D. And we want to show that these are the corners of a parallelogram. And how we're going to do that, we're going to say, all right, properties of a parallelogram. What makes it a parallelogram? Well, we had opposite sides parallel, opposite sides congruent, diagonals bisect each other, opposite angles congruent, same side interior angles are supplementary. Proving that angles are congruent or that same side interior angle is supplementary, that's a harder thing to do right now. It will be much easier when we get into our trigonometry unit. So for now, let's just leave that alone unless we are proving angles are perpendicular. That's pretty much the only one that we would try and do. And I'm sorry, lines are perpendicular, the angles are 90 degrees. So in our case here, we're going to try and prove that the opposite sides are parallel, and then I'm also going to show you how to prove they're congruent. Really, we only have to show one of them. If you can show me that you have a four-sided figure where opposite sides are parallel, it has to be a parallelogram. Same thing with congruent. But we're going to show both here just to kind of get a taste for it. Okay, so I'm using Desmos.com to plot points on my graph. If you type in the coordinate, it will, so with your parentheses, type in the coordinate, it will pop up on the graph, and you have the option of adding a label too. So if you want to get digital pictures like this, you can do that on Desmos. I would encourage most of you guys to have a piece of graph paper out at home. If you have not got graph paper, I would take some time now and maybe use a ruler and start sketching out a couple of coordinate planes, because you're going to need a bunch of them for this particular section. So here's our 4 points. We can tell, like, from looking at it, like, yeah, it looks like it could be a parallelogram, but we want to show that it is actually true. So first step, we're going to prove the opposite sides are parallel. So we got to use slope for that. Let's start with AB. Slope should be difference of the y's divided by difference of x's. We substitute in our numbers from the coordinates. I'm treating B as my second coordinate in this one. So my y2 and x2 will come from B. My y1 and x1 will come from A. Subbing in my numbers, we've got 3 minus -1. Double negative will become a positive number. And then divided by 1 minus 2. Answer would end up being positive 4 divided by -1, which is -4. So this has a slope of -4. CD, same thing, sub in your numbers. We got 1 minus 5 divided by 7 minus 6, slope once again -4. So we can tell our slopes are equal. So therefore the opposite sides AB and CD must in fact be parallel. Now let's look at just maybe a different way of doing this. So slope of BC and slope of AD. So if I wanted to do the slope of BC looking at my picture, I would say, all right, what is the rise over run? So I've got a rise of 2 and a run of 1, 2, 3, 4, 5. So that would make my slope, rise over run, 2/5. So BC, I would say slope is 2/5. Come down to AD, and we got a rise of 2 again, and a run of 5. So we once again get that slope of 2/5. So I have another pair of matching slopes, so I would say opposite sides are parallel in this case. Therefore, the shape must be a parallelogram. But now let's just say that we want to do it by proving the sides were correct. So I'll go back to my blank diagram. Proving the opposite sides are congruent. Now we're going to break out the distance formula. So this is that x2 minus x1 to be squared, y2 minus y1 to be squared, add them, square root it. Putting in my numbers for A and B again. Once again, B is going to be my x2 and y2, A is going to be my x1 and y1. So I sub in my numbers, I get 1 minus 2, which is -1, to be squared is +1, plus 3 minus -1, so it's going to be 3 plus 1 squared, which is 4 squared, which is 16. So 16 plus 1 is 17. Final answer, square root of 17. I'm just going to leave it in that radical form. You'll see why in a second, but rather than going through the problem of trying to do decimals, round decimals, and so on, if I just leave it in square root form, if it matches the square root form of the other side, then I know they are congruent. So going to the opposite side, CD, same thing again, plug in my numbers. 7 minus 6 is 1, 1 squared is 1, 1 minus 5 is -4, -4 squared is +16. Make sure you are checking your answers with that. You should be getting positive numbers for all of these. Anytime you square a positive or a negative number, you get a positive answer. So we get square root of 17 again. Square root of 17 is equal to square root of 17, so we would say the opposite sides, AB and CD, are congruent. So we got one pair of opposite sides that are congruent, which would be enough at the moment to say that we have an isosceles trapezoid, but not necessarily a parallelogram. We need to go check the other two sides as well. All right, so for this one, I'm going to use Pythagoras' theorem for this part. So we got BC. If I make my right angle triangle out of that, I'm talking about the height, the width, and then the hypotenuse of that triangle. So I've got my right angle triangle. One side's 5, one side's 2. and we do Pythagoras' theorem to figure that out. So 2 squared plus 5 squared is my missing side. We'll call it c squared. So 4 plus 25 is c squared. 29 c squared square root of 29 is that missing side. So that length is root 29. Not going to do any decimals, because if I can show the other side of root 29, then we've got the same thing. All right, so we got, there's my right angle triangle, side length 5, side length 2. So I mean, we're going to get the same answer here. We're going to get 2 squared plus 5 squared, which is 4 plus 25, which is 29. And this is all equal to that c squared. So we're going to get root 29 is c. So another pair of matching sides. And we can say opposite sides are congruent, therefore this is a parallelogram. All right, here's another example for us. Different type of question. ABCD is a rhombus. We're told it's a rhombus. If the vertices we know, so the corners we know, are A, B, and C, where is D? So you have to put point D in a place that would, in fact, make this a rhombus. So you have to complete the properties to ensure that it is a rhombus. So let's take a look at it on a diagram. All right, here's our points. Now, this one's a little bit easier to tell because the points are kind of directly across from each other on vertical and horizontal axes, but let's go through the process anyway. Things to think about. The points connect in order as given by the question. So if we have A, B, C, D, that means A is going to connect to B, B to C, C to D, and then D connects back to A. So it goes in that order. So making sure that you finish that order when you are doing this. So we're going to have A go to B, B go to C, which means D is in this zone out here somewhere. So we're going to use our opposite sides to figure out the slope. So what I'm thinking is, if I find the slope of AB, I would know that C to D would be like parallel to that. Same thing with BC and AD. So if I could do that, I would be able to figure out where they intersect and get my answer. So as we go through, slope of AB in this case, plug in our numbers, we get the slope is 1. And just looking at it, it's a run of 2, rise of 2. So if you divide those, that is a slope of 1 over 1, or 1, a 45-degree angle going upwards. Slope of BC, going from B to C, we're going back to up. So we're going down to right 2, so that'll be a slope of -1, a slope of 1. If I draw in those slopes on the opposite sides, I would get a parallelogram. And we know that in a parallelogram, opposite sides are also congruent. So if I draw in the slopes correctly, I will get the opposite sides to be congruent. And since we know it's already a rhombus, we don't have to try and check lengths. We can just say they're going to be the same. So if I do a slope of CD, so CD should be parallel to AB. So CD should have a slope of 1, and AD should have a slope of -1. So if I draw that in, so there's that slope of +1. Now you should be doing this with a ruler. I haven't figured out yet how to do a ruler with this particular type of drawing, so I am doing my best to freehand it. Which I have to say, that wasn't bad, guys. So we can see where they intersect. They're going to intersect right here, which is a quarter of -4, +1. So on your answer sheet, you would say -4, +1 is the location of the missing point, which in our case is point D. And that would complete the rhombus. And you know that's true because the opposite sides are parallel. And then because we knew that AB and BC were already congruent because we were told it's a rhombus, that would make the other sides also congruent. So properties of a rhombus have been fulfilled. A couple other things you could have done. You could have said that the slopes of the diagonals are perpendicular. So you would have been able to tell me, I know where A and C are, so BD must be perpendicular to that. So BD was going to be a horizontal line. You could count the number of boxes because it's horizontal and say, okay, that's 2 boxes. Go 2 out on the other side, that's where D must be. If you're drawing it, you could get your compass out and you could say the length of B to C, I'm going to swing that from C. So, if we got our compass out, we could swing an arc, do the same thing from A of the same side length, and they should cross at the exact same point. That would have worked as well. If you're being asked to give a mathematical reasoning, using a compass wouldn't necessarily work unless you're going into detail about why the compass proves it. So just be aware of that, whether you're just being asked to find the coordinate or if you're being asked to show using mathematics how you did it. All right, so now for the your turns. I'm going to give you 5 questions. I'm going to show you the question. I want you to try and do it on your own. And then the following slide is going to be the explanation of how to do it. So that will go, question, solution in that order. I really encourage you, take the time, get a piece of graph paper out, draw it, solve it, and that sort of thing. If you're just sketching, that's fine. You don't necessarily need graph paper for this, though it does help, I think. First one, prove that EF, G, H are the vertices of a rectangle. So you think in rectangle, like, all right, 4 90-degree angles, opposite sides congruent, diagonals are also congruent. So that's one of the things that set a rectangle apart from a parallelogram. Now I'm encouraging here to solve this by proving the opposite sides are congruent and adjacent sides are perpendicular. So when you're doing this, you need to make sure that you're proving a property that would ensure that it's a rectangle. So for example, if I just proved opposite sides are parallel, yes, a rectangle's opposite sides are parallel, but so is a parallelogram, and a parallelogram is a less classified, it's a more basic shape. So you want to make sure that you are ensuring that the shape has to be a rectangle, because that's the shape we're trying to classify. So take a shot at it now. All right, so here's our question. I put the points on a graph so we could get started. Prove that it's a rectangle, so we're going to do opposite sides congruent and adjacent sides perpendicular. So let's start with the adjacent sides perpendicular since we haven't seen that one yet. So let's see, GH, so we're going to do slope in this case, so slopes, and G to H. I'm going to use the Pythagoras theorem method, or like counting boxes. It's just simpler for me to see. So over 2, up 3. So that would be a slope of 3 over 2. If we go, next one would be HE. So we got H to E is going to be over 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4. So that'll be minus 4 because it's going down over 6, which just to check would simplify to minus 2/3. Shouldn't be an issue because the other side should be minus 4 over 6 as well, but it's always good to kind of see it, especially when we start proving that they are in fact perpendicular. EF over 2 up 3, and then GF over 6 up 4. Actually, sorry, left to right, down 4. All right, so we got the opposite sides are parallel. We kind of knew that was going to be the case anyway. We were told this is a rectangle. We're just trying to prove it. So opposite sides are in fact parallel. We got pairs of parallel sides. But to prove that they are perpendicular, one slope should be perpendicular to the other, which means that they should be the negative inverse of each other. So I take the first two, GH and HE. 3 over 2 should be perpendicular to minus 2 over 3, which is in fact what we got when we simplified the slopes. So 3 over 2 and minus 2/3 are perpendicular, so we can show that the adjacent sides are perpendicular. So adjacent sides are perpendicular, and we've proven that's true. Second part was to show that the opposite sides were congruent. So we've got the numbers here to do Pythagoras' theorem, so we've got our triangle set up. So if I want to do GH, it's going to be 2 and 3 are the sides of my triangle. So GH and technically EF, we can do these at the same time. So we got 3 squared plus 2 squared is equal to C squared. 9 plus 4. So that's going to be 13. And square root of 13 is going to be my side length for GH and EF. So they're the exact same numbers. Really, you should be doing it twice, but we can see that. If you're showing me the math once, I'm good with it. All right, so GF and then also HE. Saying they have the same slope, by the way, does not guarantee they're the same length. You will sometimes need to actually prove lengths, particularly if we're trying to disprove that it's a parallelogram. So say if you want to show it's an isosceles trapezoid and it's close, 2 sides will be congruent, 2 sides will not be. All right, so we've got 6 squared plus 4 squared is equal to that hypotenuse squared. So we're trying to prove GE. Oh my gosh, guys, my letters are terrible. GE and HF. I'm seeing it now. All right, so we're trying to prove those two. 6 squared, 36. 4 squared, 16. That's C squared. My handwriting's getting better, guys, but it's still not great yet. 52. So square root of 52 is going to be our C value. Once again, we will be able to make these smaller and simpler eventually, but at the moment we're going to leave it as is. That's going to be something that will pop up in our trig unit. So we're done. There's our opposite sides are congruent and adjacent sides perpendicular. This must be a rectangle. All right, this time, prove that it's a rhombus. Best way to prove it's a rhombus, show me that all sides are congruent. So just prove all sides congruent, you got it. The other properties, like the diagonals being perpendicular, is something you could show, but that also comes up in a kite, and we don't want to end up just proving that and then having to prove that all sides are congruent as well. Let's go for the fastest way. So prove all sides congruent. Okay, so here's our start for a solution. If you haven't paused yet, make sure you pause and get working on it. 4 sides. We can see that 2 of the sides are going to be very easy because we can count boxes, and the other 2 we can solve using Pythagoras' theorem. So we'll start with the easy stuff. The length of J to M, we can count boxes, that is 5 units. KL, also nice and easy because we can count boxes, KL is 5 units. Now JK and LM we are going to have to solve for a little bit. So let's do rise and run. So let's get that right angle triangle. So that is 3 boxes wide, 4 boxes high. So 3 squared plus 4 squared, if I'm missing side, and that will be 25 is C squared. Do the square root of both sides. Missing side length is 5. And then on the other side, over 3, up 4. So it's the same numbers. So we would say JK is equal to 5 units and LM also equal to 5. In your work, guys, I need you to show me the math at least once. So you can say the numbers are the same for JK and LM, but you can't just put down 5 unless you've shown me mathematically that you have solved it, that you know those are 5. So that means all sides are 5 in this case. This must be a rhombus. And I usually would like to see you guys put a little summary at the end. So all sides, all sides are congruent. And if you're not familiar with it, little triangle of dots means therefore. Therefore, JKLM is a rhombus. Third one. So we've got 4 corners, prove that it is a kite. And you're going to do that by showing that there are 2 pairs of adjacent sides with the same measurement, and then also show me that the diagonals are perpendicular. Go. All right, let's take a look at our solution. So we're going to start with the diagonals being perpendicular. So that means we want to show that AC is perpendicular to DB. To do that, we need slopes. So slope of, let's start with AC. So slope of AC, we're going down 2 units, right 2 units. So that'd be down 2, right 2. Simplify that, that's -1. BD, so that's 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So 5 up, 5 right, simplifies to be +1. And if you were to put it as a fraction, -1 over 1 will be perpendicular to +1 over +1, which is the case. So this is true. Diagonals are perpendicular. Second one was adjacent sides being congruent. So we can kind of see from the picture what we're trying to show. So I want to show AB is equal to BC in terms of their length. So AB, we can count boxes, that's 2. BC, we can also count boxes, that's 2. So that's 2 across and 2 down. The one we're going to have to do the math for is to prove that AD and DC are in fact congruent. So let's start with AD. AD, we've got up 5, right 3. So we got 3 squared plus 5 squared is equal to that hypotenuse squared. 9 plus 25, so that's 34. So that would mean our answer is square root of 34. Root 34. On the other side, we already have the base here is 5. Height is 3, so we know we got the same numbers, so we should be able to go with the exact same thing. So CD, 3 squared plus 5 squared, so 9 plus 25, 34, and root 34 is equal to C. So we got the matching sides and matching sides, so we got it. Adjacent sides congruent. And diagonals perpendicular. Done. Fourth one, isosceles trapezoid using the 4 coordinates. So you want to prove that one pair of sides are parallel and the other 2 sides are congruent. Go for it. Here's our 4 points. Let's get proving. So easy one, let's show that 2 sides are congruent. And like looking at the diagram, we can tell, all right, you got PQRS is the shape. So P, this is when it gets harder. That was pretty good. All right, so PQRS. We can tell that PQ and RS are going to be easy ones to actually measure because we can count boxes. So PQ is 4, RS also 4 units. So we've got two sides that are congruent. So PQ is equal to RS because they're both equal to 4 units. So now we got to prove that the other two sides are parallel. So is PS parallel to QR? That's the question. So slope of PS, we've got, let's change color quick, going down and over, 1, 2, 3, 4 down and 4 to the right. So this is down 4 over 4, which is a slope of -1 when we simplify. And then Q to R. So let's see, we go from -5 to 3, that's 8 units. And we go from 4 down to -4, also 8 units. So QR is -8 over 8, which also simplifies to -1. So we've got parallel sides and congruent sides. So we get one pair of parallel opposite sides and one pair of congruent opposite sides. Done. Last one, it's a parallelogram. You've got 3 points. Where is point R? So get it on a diagram, try and show me where point R must be. Okay, here's our points, P, Q, and S. Now the hard thing that's, well, it's not hard, it's just the thing that people forget is that the order of the letters matters. So P connects to Q. Q does not connect to S, but P does connect to S. So S is the last letter, it does connect to P. So that means that R is going to be our missing letter. QR is going to be parallel to PS, so it's going to be down in this like general location somewhere. So just figuring that out is a good place to start. Like where roughly are you aiming for? And then start going for it. All right, how I would attack this problem. I would say PQ, so PQ up here, should be parallel to SR. And they should be the same length. So if I go up 1 and right 3, I should be able to find the location of R. So I'm going to go right 3, up 1. So this should be the location of R because the opposite sides are parallel and congruent. Let's double check. SP should be parallel and congruent to QR. So this one was from Q, it was going left 2 and down 4. So I'm going to go down 4, 1, 2, 3, 4, left 2, end up at the exact same point. So in this one, you're just asked for where is the location of the missing point R. There wasn't really much math needed. I would like you to show me something that kind of gives me an idea of like how you did it. But really, it's going to be about you figuring out, okay, do I know my properties? Where should the point end up as a result of that? So we would say the coordinate of R is 4, -1. If you're asked how you did it, I said opposite sides are congruent and parallel, and use that information to help me solve it. Simple, straightforward. You've got an explanation. You're good to go. Okay, that brings us to the end of today. A little bit longer today because we had a couple of practice problems built in. You're also going to get time to practice with this. So essential questions for today. How do I prove sides are parallel? You show they have the same slope. How do I prove they're perpendicular? You show the slopes are the negative inverse of each other. How do I find a missing point on a shape? You use the properties to help you figure out where that missing point should be to make the properties of the shape true. So if it's opposite sides parallel or opposite sides congruent or perpendicular, whatever it is, use that information to help you find the missing point. All right, so your task for yourself. you've got a quiz to do based on the stuff from last week. That is going to be in Schoology for you to complete. And then I also want you to do, there's a PDF posted after this of questions about proving shapes using coordinates. I want you to do all the questions on that. Do it on a separate sheet of paper. So get your piece of paper out, draw your coordinate plane, plot the points, do the proof, and then I want you to take a picture of one of your completed proofs. So all I'm asking for is a picture of one. Post that just to show me that you got, kind of what you're doing. Try and make it like what you thought was maybe the hardest question on the paper. So if you're like questioning like whether you did one right or not, that would be the one I would post. And then on the discussion board, please like put down if you're having trouble. Say like which question you're having trouble with, describe it, or say, hey, what did you guys do for this particular question? And then start responding to people as well and letting them know this is what I did. Using pictures of your work is a great way to show what you are doing, or take a quick recording of what you're doing and post that. You can post videos in Schoology as well. The more you guys help each other, the better your understanding is going to be and the easier you're going to find all of this stuff. All right, that is going to be us for this week. So you've got quiz, this content, and the practice problems. That will get you to Wednesday. Make sure that all your other stuff is turned in. We will not do a journal for next week. So yeah, don't worry about that. And we'll start one the following week. All right, guys, have a good rest of your week. Have a good spring break, and I will see you when we get back.